Hello everyone. So this is a question from RE-NEET 2026. One of the products formed in the following reaction is, so we have a reaction here and the chapters involved is haloalkanes and haloarenes. Okay. So in the reaction you can see we have a Grignard reagent. Okay. And they are generally represented as RMgX. Okay. In Grignard reagent the carbon magnesium bond, that is this particular bond, is covalent. Okay, but it is also highly polar, so it is covalent and highly polar. Okay, bipolar, I mean it has charge separation of positive and negative charges. Okay, and it is polar because there is a huge or a large electronegativity difference between carbon and magnesium. Okay, so it is polar because due to large electronegativity difference between carbon and magnesium. Okay, and to be specific, the electronegativity of carbon is 2.5 and the electronegativity of magnesium is 1.2. Okay, so therefore carbon has more affinity towards electron because its electronegativity is more. Okay, so therefore these electrons, they spend more time near R, or you can say near the carbon, okay, compared to magnesium. So therefore I can show partial negative and partial positive charges here. Okay, and because of this high polarity of this RMg or CMg bond, these guys, that is Grignard reagents, are potential source of carbon ions, very important. Okay, so because of high polarity of the CMg bond, Grignard reagents are potential source of carbon ions, and carbon ions are species bearing a negative charge on carbon. Okay, so these are those species in which there is a negative charge on carbon. Okay, that is, with respect to diagram I can show it to you. For example, R mgx, so these electrons are spending most of the time near R, that's why it has a negative charge. This magnesium has a positive charge, so that's why this guy behaves as a carbon ion. Okay, so therefore in a nutshell I can say that Grignard reagents are very reactive. They react with any source of protons or acidic hydrogen to give hydrocarbons, very important. Grignard reagents react with any source of protons or acidic hydrogen to give hydrocarbons. Okay, so what are those sources? So those sources are, Grignard reagent can react with water, it can react with alcohols, it can react with hydrogen sulfide, it can react with ammonia, it can also react with 1 degree and 2 degree amines, and also it can react with terminal alkynes as the hydrogen in them is acidic. Okay, so these are some of the reagents with which Grignard reagents can react. Okay, so these guys, they are sufficiently acidic, and by acidic I mean, so these guys can donate their protons to the Grignard reagent. Okay, and it converts the Grignard reagent into hydrocarbon. Okay, so in our case the Grignard reagent, that is this guy, is reacting with this guy. Okay, so this guy, it is actually cyclohexyl amine. Okay, and also um, this is a 1 degree amine because you can see nitrogen is connected to one carbon. Okay, so Grignard reagent will react with it to give us hydrocarbons ultimately. Okay, so as we have written, Grignard reagents will react with 1 degree amines to give us hydrocarbons. Okay, so Grignard reagent plus 1 degree amines will give us hydrocarbon. Okay, so with respect to reaction, I can write the specific Grignard reagent. So it is MgBr plus the primary amine that they have given. So I will write it in this fashion. I will separate one H. Okay, so we know the charge separation. Here we will have a partial negative charge. Here we will have a partial positive charge. Here also nitrogen more electronegative compared to hydrogen. That's why nitrogen will have a partial negative and hydrogen will have a partial positive charge. Okay, so this carbon gets this hydrogen, and therefore in that process it becomes cyclohexane. Okay, so initially it had one hydrogen, now it has this hydrogen also, so there are two hydrogens here. Okay, and everywhere else also we have two hydrogen, we just don't write or mention it, but it is there. So therefore this is cyclohexane, and this Mg had a bond with Br, and since it is positively charged, it will bond with the rest of the amine after it has lost this hydrogen. Okay, so it will form a bond with this NH and the ring. Okay, and this bond is ionic. Be careful, these bonds are ionic because magnesium is a metal. It has negative charge, and this is the positive, sorry, it is a metal, so it has positive charge, and these guys have negative charge. So this is, this contains ionic bond. This is the other product, and the main product is cyclohexane. And I mean, there is one extra information, that is, since we learned that Grignard reagents are very, very, reactive, and they will react with any source of protons. Therefore, in most of the reactions of Grignard reagent, you will always see above the arrow, you will see a word dry ether. Okay, and so this is the solvent in which we do reactions of Grignard reagent, because these ethers, dry ether, don't react with Grignard reagent. Okay, so that's why we use this as a solvent. Because if the solvent reacts with Grignard reagent, the Grignard reagent will become into, or it will turn into a hydrocarbon. So it will lose its, importance. So coming to our question, the final answer is um, cyclohexane. Okay, cool. Thank you.